There's one other technical idea that proved to be super influential. So if you look at what this model is doing at the recurrent stage, it's keeping on multiplying by the same matrix WH, and that proves to be very problematic. So people came up with this idea of maybe what we should do is have a bypass where the previous state would just be passed straight forward past the next piece of neural network. And so effectively, we've got something like an updating memory so that you could just pass forward stuff that was already in the memory, or you could run stuff through a neural network and update parts of the memory. That doesn't seem a very complex idea, but it was completely transformative for getting large recurrent neural networks to work in the so-called LSTMs, which became so famous that they got mentioned in an Apple iPhone keynote. And it's also been exactly the same idea that has allowed very deep networks to work visually. So any of the kind of ResNets and ResNext that Jitendra was mentioning before, where people are building very deep networks now in vision, are using exactly the same idea of adding a bypass. Something that's even more surprising is once we had this idea of a language model, we could literally just butt two of them together and say, we can use this as a machine translation system. We will read in an input sentence and run it through our recurrent net, and then we'll have a second recurrent net for a different language and say, based on that initial state, start generating words. And again, the powerful idea is that we have a defined loss function at the end, and we just run this on lots of pairs of sentences and their translations, and the neural network can simultaneously optimize all of the parameters to make this work. Of course, really, we make the network deeper and bigger, but it's, again, quite amazing and phenomenal that simply doing this allowed one to use this sort of simple regular architecture and build a machine translation system which worked better than anything that existed before. Any of the kind of traditional NLP systems or statistical NLP systems with lots of hand-built modeling components for word order, syntactic structure, different forms of words, that simply optimizing in a big neural network is actually giving you more power. There's still one big limitation of having this structure that I've shown here, which is all the information the source sentence has to pass through one time step where it's then used to generate all of the output. So we kind of have a bottleneck between our two neural networks. That's unlike what a human translator would do, because a human translator would look back at the source sentence and translate bits of it as they go. And so that's led to a second important stage of development in what we now use everywhere, which is the idea of attention. So now when we're running our generator neural network, we say, let's use this hidden state to also look back at the source sentence. So again, we're going to use a fairly simple similarity calculation, a kind of generalized dot product, to say which source sentence hidden states are we similar to. We're going to work out, based on that similarity, distribution over our extent of similarity with different source states, and then we're going to create a weighted average of the source hidden states, and then we're also going to use that to inform the next word that we generate. And this idea of attention has proved to be a second hugely successful idea for powering modern neural networks this decade. Once we had those two ideas, we could then produce machine translation systems that were just much better than what used to exist. So here's showing one evaluation where the Edinburgh, Karlsruhe, and Heidelberg systems were kind of state-of-the-art statistical machine translation systems from around 2014-15. And using a neural machine translation system instantly gave us about a 25% reduction in the error rate, which is, again, a huge leap by the standards of these systems. In fact, neural machine translation was so much better than what preceded it that this led to an extremely rapid commercial transition. So it was really only in 2014 that people first started playing with neural networks for doing machine translation, and only 3 years later, basically all of the large tech companies are using it and finding much better results.